So moving on with our project, now we have to separate the features and the labels. So separating features and the labels. So see, what is going to happen that my X will be input features and Y will be my output features. Now we have to see, okay. So X will be equals to np.array array. First I need this one, this data frame, features underscore df. And from this data frame, I need features. This one. And here I need to convert it to list. Okay, so this is done now. Now, similarly, now for y I need, see, in case of y, if you remember in the metadata, one class ID was given. Along with the class, this class ID was also given. So we will use that class ID for my y feature, okay? So y will be equals to metadata. If you are getting confused, metadata dot head, we can check it here also. See here, for this class, this is the class ID. For example, dog bark is 3, children playing is 2. So I will directly use this class ID, okay? So y is equals to metadata of class ID and convert it into toList. Or rather simply values, sorry. Okay, so x and y split is done. Let us see the shape. So x dot shape 8732, 40, which is correct as per our MFCC coefficients. And y dot shape is 8732. So 8732 are there. After this, we have to perform the train test split. So train test split. So from sklearn dot model selection import train test split. So x underscore train, x underscore test, y underscore train, y underscore test. This will be equal to train test split x. Did I make some mistake? No, I don't think so. Okay. X, comma, y, comma, random state. I have to give test size. Test size will be I'll take it as 0.2. 20% of the data is testing data and random state. Random state, let me put any number, any random number is fine. Okay. Let us see. Okay, successfully executed. Just I'll check the shape for confirmation. Okay, 6985 40. This is correct. Now, after this, we have to perform feature scaling. Feature scaling. See, we need to do the feature scaling so that it is all in one scale. Means the values can range from wide range, right? The MFCC coefficient. So I want it in the same range. So for that, from sklearn dot preprocessing import standard scalar. This is done. So scalar is equals to standard scalar. This is also fine. Now x underscore train will be scalar dot fit underscore transform. underscore train. And in case of test, it will be scalar dot only transform. Basically, it means that to calculate the value of this coefficient of scaling, only train data was used. Test data was not used. So this is done here. We have done two steps. We have splitted it in. We have split our data set into training and to input variable and target variable. Furthermore, we have again split it into two parts, training and testing data set. In the next section, we will be building the neural network. So let's meet there.